Hello guys, I guess we are live. So I hope you are able to hear me. Hello. Okay, so let's start off with our today's C++ learning. Um, so let's just open up. So yesterday we were doing arrays. So we completed. So yeah, I think we completed up till here. So let me just open up my VS Code. All right. So we are doing this one. Till yesterday we did till here. Next program is to find the size of an array. So let me just copy this code and I'll just paste that. I will just comment this out. All right. Just a minute. Just a minute, guys. All right. Anyway, okay, guys. So let's continue. Let's have it one side. Okay. So this side. Okay. All right. So to find the size of an array, the array does not contain the information about its size, but we can extract the size using the size of operator. All right. So let us try this program. All right. Here they have taken a character array. All right. Okay. Let us just keep it as an integer array. Um, Size of one element of an array. Okay. That is just for a single element. Okay. So let's try that first. And also let's print size of ARR itself. That is the whole array. Let us try that. So the syntax will be the same, except for size of, we give you just ARR, and then size of, here this is the change. So we have to just give ARR instead of ARR of 0 or whatever, anything inside the brackets, because we need the whole array size. So, and okay. So That will print the size. Okay, first let us compile this and see what we get as an output. And later we can find out this length of an array. So let us compile this first. All right. Okay, I think I haven't saved. Okay, let compile. Let me run it again just one more time to be sure. All right, cool. Now, yeah, now we got size of ARR of 0 as 4 and size of ARR is 20. Hmm, interesting. Anything we did wrong here? Let me check. I don't think so. Size of, let me just go into, okay, then it was correct, guys. Size of an integer is 4 bytes. So every integer takes up 4 bytes here. So if you add all of it, you will get 20. So that's why 20. So for us, it's correct because they considered characters, and characters will take only 1 byte as mentioned here. Then you will get, as they got, 1 and 5. All right, so we have done it correctly. Let us also find the length. Okay, let's see. So for finding a length, int n equal to size of ARR. So no built-in there's no built-in function or anything to find the length. So we have to first initialize it here. So let me just do that. So this part, what do they do here? They're taking the whole size and then dividing it by the size of the first element, which would be the length, which is correct. That makes sense. Let us just, all right. So I don't know how many of you guys are watching right now. If you are here, let me know in the chat. All right, let's continue. Um, Now we have to print this. So see out length of an array, length of an array, and then this is actually just n, and then return. Okay, all right. I think that is good. I'm gonna save this. I'm going to compile, and yeah, we got length of an array as 5, which is just size of error 20 divided by the first size of the first element. So we got 5. So that is correct. All right, let's move on. Hmm. Okay, so let's go to the next part. Okay. What else is there in arrays? I don't know if okay, there are some practice problems here. Okay, all right. Let me check here. Uh, all right. So let's move on. Let's go to the next topic that's mentioned inside of here. That was a brief like practice of arrays. Let's do pointers next. All right. Pointer is a special variable that holds the memory address of another variable rather than storing a direct value itself. Pointers allow programs to access and manipulate data in memory efficiently, making them a key feature for system level programming and dynamic memory management. When we access pointer directly, we get the address it holds and not the actual data stored at that location. This is the this last point is most important. Um, okay, let's create a new file for pointers. So let's name it as pointers. Pointers. Pointers one dot cpp. Okay, and let me just uh, right. All right. Use here this one too. All right. Now we are good. Okay. So here to declare a pointer and store the address of this variable, this is the syntax. Okay, first let us initialize the variable and var equal to 10. And now to access this, not accessing actually, first declaring the pointer. So int star ptr equal to ampersands var. Okay. So now to print the value and address. First, we are printing the value. To print the value, it's pretty straightforward. We just say var, see out value of var, and then float it, var, just handle. Now we have to print the address. So we say value of address of var, and here is the difference. We go with ampersands var as we did here, and handle. All right. And in the last, this portion, it prints the value stored in the pointer PTR. So the first time we just printed the value directly. Now this time we are going to print the value which is inside the pointer that points to VAR. So which is also again 10 only. So let me just check that. Okay, that's not going to be 10 actually, because the value stored in the pointer PTR is just the address again. So, that address points to a different location, but the value there is only the address. So, this will only be an address. And then again, when you are printing star PTR, that is when it prints the value that is stored, like value that is inside that address. Hold on, let's check that out first. Let me just check this. Value stored in pointer ptr, and here we are just saying ptr. So, and then again it's going to be value pointed to value pointed to by ptr, by the pointer. So for that we have to go with star ptr, star ptr. All right. So now let us End the program, return, return 0, and we are good. All right. So let us save it and let's just run, see what happens. It's going to be pointers. All right. Compile. Okay, it compiles. Here, got to be pointers one. All right. So there you go. We have got the value in the variable, which is 10, and we access, we get the address of that variable, and then later that address is stored in a pointer, and then that value is printed by just ptr, and that value is accessed again with star ptr. All right. So that is the basic pointers program. All right. So we have, all right, this is a pictorial representation what we did. All right, let's continue. Print star ptr, which is declaring a pointer to an integer, and then ptr equal to ampersands x. This x is usually say ampersands var, or if you are declaring x here, then it's ampersands x, whatever it is. And star ptr is called a dereference operator. It gives access to the value stored at the memory address ptr is pointing to. All right. Okay. So ptr holds the address of x. ptr holds the address. Star ptr gives the value of x by accessing that address. Create pointer. The pointer can be declared. So for pointers, we just it's just the same convention as how we declare a variable, but we just do it this way. That is the data type, and then the star comes in after that. So the asterisk symbol. So that's how you declare a pointer. Okay, we have done all this. Dereferencing, the process of accessing the value present at the memory address pointed by the pointer. Okay. which is what we did here. That is dereferencing. All right. Directly accessing the pointer will just give us the address. That is true. The pointer can be modified to point to another memory address if it is of the same type. All right. So here both are integers and the pointer is declared over here for A, and then that value is accessed, as you can see, star PTR, and then changing the address stored. Okay, 0 PTR equal to ampersand B. All right. How many of you guys are watching right now? Not sure. So, guys, if someone is watching, please drop a hi in the chat so that I can know. Also, please do like the video if you are enjoying this session. So, changing the address stored. All right. Here, with just this, we are changing it to another memory address. All right. Okay, this makes sense. Maybe we'll just try this one out here. All right, let's try this out. Okay, so let's create two integers and let's say var2 and 20 and int star ptr equal to ampersand var, and also we'll do int. Okay, let's do cout first. Cout, let's print that out. Star ptr and then okay. Then after that, we're doing ptr equal to changing that to be cout star ptr. All right. Okay. I guess there is an error here. Okay, cool. I think we are good. Hopefully, yes. Okay, there's probably another error here. Hmm. What is wrong? Not sure. What went wrong? I think it is. Let me see. Is it star PTR here? Not sure. Oh, no. Let me see. Include path. Something went wrong. Not sure. Okay. Here we have declared the second variable as var2. Okay. No issues. Now I think we are good. Let me just save. I cannot. All right. So we got the output 10 and 20. All right. So that was how to change the address or how to make the pointer point to another address. Size of pointers. Okay. Size of pointer. Okay, so it's dependent on the operating system CPU or architecture. All right. 8 bytes for a 64-bit system and 4 bytes for a 32-bit system. Okay, so let's try this one. Let's try out this one. Size. So we are initializing two pointers. We're directly initializing here. So int star ptr or int star ptr1, and here we are taking character well, ptr2, see out. All right, size of ptr1. Like the video if you're watching, guys. It helps it to reach to more people. Size of ptr2 so that returns the sizes. Let's check out. Yeah, so there you go. 8 and 8. So both the pointers have the same size, 64-bit system, so the size is 8 bytes. Special types of pointers, wild pointer. Okay. When a pointer is created, it just contains a random address that may or may not be valid. This type of pointer is called wild pointer. Okay. So let's see what dereferencing this pointer may lead to errors such as segmentation false. So it is always recommended to initialize a pointer. So we are not really, we have not initialized the pointer. We are directly going ahead and creating it. So that is a wild pointer. Okay. Null pointer. Null pointer is pointer that does not point to any valid memory location. Is often used to initialize a pointer when you do not want it to point to any object. All right. So null PTR. So there is no variable. It's just null PTR. All right. What is void pointer? Okay. Let me check the chat, guys. I don't know if any of you is watching right now. Please drop a hi and let me know if you have any questions. Whether okay. So it's void star for declaring this kind of a pointer. Earlier we just used to do like the data type and star. Here we do void star. Okay. So a void pointer cannot be directly dereferenced. This is the point to remember here. Must be explicitly typecast to approximate to the approximate pointer type. All right. So here we typecast it. Let's actually try this one out. All right. So let's write this code over here. First, we are just initializing a variable, so I'll just call it var1, and then void. So void pointer, so void star ptr equals to ampersand var cout. We are just accessing it. Cout value pointed by void pointer star start static as you are, this is where we are doing the typecasting. Static underscore cast, and then int star, and then close it. Okay. Okay, don't have to close it yet. PTR. Now we can close it. Handle. Okay. So this is the code. All right. That is pretty large syntax. Anyway, this is how you can typecast it to an typecasting it to an integer, because it is a void pointer. So this is how we can typecast it before we actually dereference it. So this asterisk here is the dereferencing part, and here we have just typecasted it. So that is the typecasting part. All right. So let me just try and see if this works. File. All right. Yeah. Value pointed by void pointer is 1. It is 1 here. So we are good. Dangling pointer. So that was void pointer. Then it is dangling pointer. All right. So what is a dangling pointer? Refers to memory which has been already been freed or is no longer valid. Right. Hmm. Dereferencing a dangling pointer leads to undefined behavior. Okay, let's try this out. All right. Okay. So here the syntax little bit is a little bit different. All right. Let here. Okay. So the main point is that here we are declaring the pointer outside the scope, which is outside the main function. All right. So it goes outside here. Get pointer and int x. Now it's outside our main function. So also we are returning x, that is the address here, ampersand x. So returns the address, and here inside the main, what we have to do is int star, call this function here, get pointer. So this is where it becomes dangling. All right. So int star ptr get pointer. So let's try what happens here when I just run this. Okay, I did not save it. Let me save it. Okay, all right. So there is the error as mentioned here. So yeah, that was about dangling pointers. Okay, okay, pointer arithmetic is the next topic we have. Okay, how much? Okay, there is quite a bit inside pointer arithmetic that we need to learn. All right, so let's let's do that tomorrow, I guess. I think there is enough done for today. So yeah, I hope you guys enjoyed this live stream. Um, I don't know how many of you guys joined. Anyway, keep tuning in, guys. It's your support that makes me continue doing this. So until the next one, see you.